Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 10 students and the topic of discussion is surface areas and volumes. This is the second video on this particular topic. In the first video, we introduced surface area and volumes for different solid objects such as cube, cuboid, cone, cylinder, sphere and hemisphere. In this particular video, we will be focusing on extra punch problems or the hot questions. They are examination oriented problems, so pay attention here students and be ready with pen and paper. In the first problem, the sum of the radius of base and height of a solid right circular cylinder is 35 cm. Radius of the base r and the height of the cylinder is 37 and the height, so it means r plus h is 37. It is given here. If the total surface area of the solid cylinder is 1628 square centimeter, we need to find the volume of the cylinder. We know that volume of the cylinder is given by pi r square h. So we need to get r and we need to get h, then we can compute the volume. So we start from what is given, like total surface area of cylinder is 1628. What is total surface area is the curved surface area plus two circular areas on top and bottom. So those two areas are given, like total surface area as 2 pi rh, which is the curved surface area, plus 2 pi r square, the two areas of the two circles on top and bottom. So from this expression we take 2 pi r as common, 2 pi r bracket r plus h, we can write this expression. What is r plus h? R plus h is given as 37. So we write 2 pi r into 37 equal to 1628. 1628 is given here. So from this equation we can get r as 7. We will put pi as 22 by 7. Since r plus h is 37, we can get h as 37 minus 7, which is equal to 30. Now we got both r and h, so we can compute volume of cylinder as pi r square h. R is 7 square, h is 30, pi is 22 by 7. Multiplying, we get volume of cylinder as 4620 centimeter cube. In the second problem, a right circular cone of radius 3 cm has a curved surface area of 47.1 centimeter square. Find the volume of the cone. So what is the volume of the cone? 1 by 3 pi r square h. So we require r as well as we require h. R is already given here, 3 centimeter. So we need to find height of the cone first before computing the volume. So what is given now? Curved surface area is 47.1. So what is curved surface area of a cone? Pi rl. So pi r into L equal to 47.1. We get L as 5. L is the slant height. So from Pythagoras theorem we can get h as square root of L square minus r square. 5 square minus 3 square under root 25 minus 9, 16, under root is 4. So volume of cone is now computed as 1 by 3 pi r square h. Substituting with the value of r and h, r as 3 and h as 4, we get volume of cone as 37.68 centimeter cube. In this problem, we have a decorative block made up of two solids, a cube and a hemisphere. This is a cube and we have put a hemisphere on the top. The base of the block is a cube of side 6 cm and a hemisphere fixed on the top has a diameter of 3.5 cm. We need to find the total surface area of the block. If this hemisphere was not there, then the total surface area of a cube is 6a square. A is the side of a cube which is given as 6. But now a hemisphere is put. Once a hemisphere is put on top of one of the sides, this particular small circle over which it is kept on the cube, that will be hidden, or its surface will be closed. So we have to subtract minus pi r square, which is hidden now, that particular surface. However, additional new surface like this dome shape is now added. For a full sphere, the surface area is 4 pi r square. For a hemisphere, this will be plus 2 pi r square. So this is the surface area of cube. We have added the surface area of hemisphere. Minus pi r square is the surface of the circle, which is hidden because hemisphere is put on that. So we find 2 pi r square minus pi r square as pi r square. Now we substitute a as 6 and r as 3.5 by 2. Since 3.5 is the diameter. So on calculation of this expression, we get total surface area as 225.6 centimeters square. In this particular problem, we have a conical vessel with base radius 5 cm and a height of 24 cm. This is filled with water. This water is emptied into a cylindrical vessel of base radius 10 cm. Find the height to which the water will rise in the cylindrical vessel. For such problems, we have to equate the volumes. That is, volume of the cylindrical vessel is equal to the volume of water in the conical vessel. So what is the volume of water in cylindrical vessel? Let its radius be capital R and height be capital H. So pi capital R square H equal to volume of water in the conical vessel, which is 1 by 3 pi R square H. Pi will get cancelled. What is R here? R is 10 centimeter for the cylindrical vessel. So 10 square H height is to be computed. R for the conical vessel is 5 centimeter and its height is 24. So we will substitute here 5 square into 24. On simplification, H will be 2 centimeter. This is the final answer. So before we come to the next problem, we want to introduce you to two new concepts. That is, what is frustum of a cone? So this is a cone here, conical shape. We take a parallel plane, this blue color, and we'll cut this cone parallel to the base. And this portion of the cone is removed. So what the remaining solid here with the orange color, this is the resultant solid. This is called a frustum of a cone. So it is defined like this. This is the frustum of a cone of height h, base radius capital R, top radius small r, and the slant height as L. So what is the volume of this frustum of a cone? Volume of frustum of a cone is given by 1 by 3 pi h bracket capital R square plus small r square plus r into r. What is the curved surface area? Pi r plus r into L. For a cone it is pi rl. Here now two r's are there, so you will write it as pi r plus r into L. L is the slant height. Then another important concept is the midpoint theorem. If a line segment adjoins the midpoint of any two sides of a triangle, we have a triangle ABC where D and E are the midpoints of the sides. AB and CE we have denoted like that with the dash symbol, double dash. It means A is equal to EC and AD equal to DB. Then according to the midpoint theorem, DE is parallel to BC. DE is parallel to BC and DE is equal to half of BC. This is midpoint theorem. So we will use this concept of frustum of a cone and midpoint theorem in our next example. In this problem, we have a solid cone of base radius 10 centimeter and it is cut into two parts through the midpoint of its height. So it is cut into two parts through the midpoint. So if h is the height, the new height or where it is cut is h by 2 by a plane parallel to its base. So through this plane which is parallel to the base, we need to find the ratio of the volumes of the two parts of the cone. That is, we need to find the volume of this cone and then the volume of the frustum of a cone. Now, according to midpoint theorem, BC is equal to half of DE. We already explained previously. So if this is 10 centimeter, DE is 10 centimeter, BC will be 5 centimeter. Now we need to find the ratio of volumes of the two parts. So volume of cone divided by volume of frustum of a cone. We know volume of a cone is 1 by 3 pi r square h. 1 by 3 pi r. R is 5. This is 5. So 5 square, and the height is h by 2 for this conical region. Now we find the volume of frustum of a cone, that is this bottom region, which is 1 by 3 pi h. H is here h by 2. This height is h by 2 plus capital R square 10 square plus small r square 5 square plus capital R into R, that is 10 into 5. 1 by 3 pi will get cancelled. H by 2 will get cancelled. So solving this, we will get the ratio as 1:7. In this problem, from a cuboidal solid metallic block, we have a cuboidal metallic solid block of size 15 into 10 into 5. It means 15 is the length, 10 is the width, and 5 is the height. A cylindrical hole of diameter 7 centimeter is drilled out. So we have drilled a hole across this length. We need to find the surface area of the remaining block. Now once we drill a hole, these two circular areas will be removed from the surface area, top and bottom, since it is drilled throughout. However, new surface indicated by these dots are added up. So these are the curved surface area of the cylinder. If you look from top, we can see new surface inside, which is this denoted by dotted lines. And these two circles are removed. So the new surface area will be surface area of the cuboid plus curved surface area of the cylinder, which is newly created because of drilling, minus 2 into area of circle. These two circular area we need to remove. The surface area of cuboid is 2 into LB plus BH plus LH. What is the curved surface area of cylinder? 2 pi RH, and 2 into area of circle is 2 pi r square. So length is 15, breadth is 10, height is 5. We substitute here. R is 7 by 2. Since diameter of the hole is 7, its radius is 7 by 2. On substituting in this equation, we get surface area as 583 centimeter square. In this problem, a sphere of diameter 12 centimeter is dropped in a right circular cylindrical vessel, partly filled with water. If the sphere is completely submerged in water, the water level in the cylindrical vessel rises by 3/5 by 9 centimeter. So what is this partial fraction? 3/5 by 9 is 9 into 3, 27 plus 5, 32 by 9. So this is fraction is 32 by 9. We need to find the diameter of the cylindrical vessel. So this is before the sphere is put. Once we put the sphere, because a sphere is added in this water, water will rise by this 32 by 9 centimeter. We need to find the diameter of the cylindrical vessel. So the volume of the water raised is equal to volume of sphere. So what is the volume of water raised? Pi r square h, cylindrical volume. And what is the volume of the sphere? 4 by 3 pi r cube. Pi will get cancelled, r square will keep it, and h is 32 by 9. This partial fraction is converted into fraction, and r is 6. given. The sphere of diameter is 12, so its radius is 6. So we on substitution we get R as 9 centimeter. We need to find the diameter of the cylindrical vessel. So its diameter will be 18 centimeter. In this particular problem, water is flowing through a cylindrical pipe of internal diameter 2 centimeter. So we have a small pipe here through which water is flowing in a bigger cylindrical tank of base radius 40 centimeters. So radius is 40 centimeter at the rate of 0.4 meter per second. Determine the rise in level of water in the tank in half an hour. Half an hour means in 30 minutes. Here one important formula is there, that volume of water through pipe is given by area into velocity. So area for this is pi r square, its radius is 1 centimeter. So pi into 1 square, since this is in centimeter and velocity is given in meter per second, we multiply this by 100. So 0.4 into 100. So this will come in centimeter units. Then we need to find in half an hour. This is per second. This volume is per second. This, so into 60 will be per minute, into 30 will be in half an hour. So this is the volume of water which has gone inside the tank, which is equal to pi r square h. That is the volume of the water inside the tank. R is 40, so h can be computed as 45 centimeter. So if this particular pipe flow is going at this rate, this size 2 centimeter in half an hour, water will rise by 45 centimeter. Friends, with this we conclude this video. I request you to please subscribe my channel and give a thumbs up to this video. This will motivate me to make more such good videos for you. Thank you very much, friends.